Welcome back to another video. In this lecture, we will find out the maximum and the minimum number of nodes for a binary tree, for a full binary tree, and for a complete binary tree given height h. Given height h, right? For example, first we will look at the maximum number of nodes for a binary tree given height h, right? So whenever these kind of questions are given, we will just try to take an example, then try to reduce the formula, and then use that formula to find out the maximum number of nodes. If we don't remember the formula, if you remember the formula, it is very good, but if you don't remember the formula, try to use an example to deduce the formula and then use that formula to find out the maximum number of nodes. For example, given height h, for example, let us take h equal to 3, right? For h equal to 3, first I would like to draw h equal to 1. So here I say A and B, right? A and B, and here height equal to 1. Why? Because there is a single edge connecting A and B. Therefore here in this example, for height equal to 1, I have drawn this, right? So can you please tell me whether these are the maximum number of nodes for height equal to h, for h equal to 1? I don't think so, right? Because for h equal to 1, I can also draw another node C. Now we have the maximum number of nodes. Now you cannot draw any more nodes, like you cannot say here D. Why? If you say D here, this becomes a non-binary tree. So we want maximum number of nodes for a binary tree, right? So for h equal to 1 or height equal to 1, the maximum number of nodes are 3, right? Let us now draw for height equal to 2. For height equal to 2, right? This. Now this is height equal to 2. Is this the maximum number of nodes for height equal to 2? Can I put any more nodes? Yes, I can, right? So here I can say E. So is this the maximum number of nodes? No. I can also have these nodes, right? G. Now I have to stop, because for height equal to 2, these are the maximum number of nodes I can insert in a binary tree. I cannot insert any more nodes, right? Suppose if I delete this, is this the maximum number of nodes for height equal to 2? No, right? So once I inserted G here, then we have the maximum number of nodes for height equal to 2, right? So the maximum number of nodes for height equal to 2 is nothing but here, as you can see, 1 2 3 4 5 6 7, right? Let us do for height equal to 3 h, right? For height equal to 3. So is this the maximum number of nodes? No. So is this the maximum number of nodes? No, there can be more nodes, right? J. No, this is not the maximum number of nodes. K. There are still more nodes we can insert, right? L, M, N, O. So here I have to stop for height equal to 3, because I cannot insert any more nodes. If I insert any more nodes in this height, it becomes a non-binary tree, right? What is a binary tree again? A binary tree is a tree which is either 0 or 1 or 2 child nodes. In this tree you can check, every node has either 0 or 1 or 2 child nodes, right? So here in this binary tree, every node has either 0 or 2 child nodes, right? So here for height equal to 3, the maximum number of nodes are 15. Now for h equal to 1, maximum number of nodes are 3. For h equal to 2, maximum number of nodes are 7. For h equal to 3, maximum number of nodes are 15. So from this, from this height, we might struggle to reduce the formula. So can I say like this, for the root, I can say the number of nodes are 2 to the power 0, which is 1, right? For this level, I can say 2 to the power 1, which is 2, right? Which is 2. I'll just circle this so that there won't be any confusion here, right? In this level, I can say 2 to the power 2, that is 4, alright? I'll circle this. In this level, I'll say 2 to the power 3, that is 8. That is 8. So on for 2 to the power h. 2 to the power h, right? 2 to the power h. As you can see here, for this level, 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power h, right? 2 to the power h. So here I can say 2 to the power 0 plus 2 to the power 1 plus 2 to the power 2, right? So here this is level 0, level 1, level 2, level 3, right? For 3 levels I have the heights, right? So plus 2 to the power h is equal to 2 to the power h plus 1 minus 1, right? 2 to the power h plus 1 minus 1. This is our formula. This is our formula. This is a GP series. This is our formula. So let us take this example here and let us do it for height equal to 3. So let us use this formula. 2 to the power 3 plus 1 minus 1 equal to 2 to the power 4 minus 1 equal to 16 minus 1. That is nothing but 15. That is nothing but 15, right? So we got the same answer, right? As you can see, for height equal to 3, how many number of nodes are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, which is exactly the same answer we have got here. So the maximum number of nodes for a particular height for a binary tree is nothing but 2 to the power h plus 1 minus 1. H plus 1 minus 1, right? I hope you have understood this, right? Now let us look at the maximum number of nodes for a full binary tree. Maximum number of nodes for a full binary tree. Just using some common sense, we can clearly see that if the maximum number of nodes for a binary tree is 2 to the power h plus 1 minus 1, the maximum number of nodes for any kind of binary tree, I am talking about the maximum number of nodes. So the maximum number of nodes for any kind of binary tree would be 2 to the power h plus 1 minus 1 only, right? Whether it is a full binary tree or whether it is a complete binary tree, right? It has to be 2 to the power h plus 1 minus 1. Therefore for the full binary tree also, maximum number of nodes are 2 to the power h plus 1 minus 1. For a complete binary tree also, 2 to the power h plus 1 minus 1. I hope you have understood this one. Yes. Now let us look at the minimum number of nodes for a binary tree. Right? So now I'll just delete this one. Let us look at the minimum number of nodes, right, for a binary tree. Right? For a binary tree, let us take h equal to 3, for example. Let us take h equal to 3. Now for a binary tree, right, I'll draw this. Let us look at h equal to 1 first. When I say h equal to 1, what are the minimum number of nodes? The maximum number of nodes are 3, which you have seen, but the minimum number of nodes are 2 only, right? If I want to draw a tree with height equal to 1, I need at least 2 nodes. Again I repeat, if I want to draw a binary tree with height equal to 1, I need at least 2 nodes, because for an edge to be there, I need at least 2 nodes. Without 2 nodes, there won't be any edge, right? So here the number of nodes are how many? 2. Number of nodes are 2, right? Now for height equal to 2, here if I want to draw a binary tree with height equal to 2, the minimum number of edges or the minimum number of nodes that have to be there are 1, 2 and 3, right? So for height equal to 2, the number of nodes are 3. Yes, A, B, C, 1, 2, 3. Number of edges are 2, which means that height equal to 2. So for height equal to 2, number of nodes are 3. What about height equal to 3? Right? What about height equal to 3? A, B, this is height equal to 1, right? C, this is height equal to 2. What? Height equal to 3. Height equal to 3, which means that I have 3 edges. 1, 2 and 3. For height equal to 3, what are the number of nodes? Number of nodes are 1, 2, 3 and 4. So we can clearly see there is a formula here. For height equal to 1, 2, right? For height equal to 2, 3. For height equal to 3, number of nodes are 4. So can we write like this? The number of nodes, the minimum number of nodes for a binary tree is height equal to, number of nodes equal to height plus 1, n equal to h plus 1, n equal to h plus 1, right? I hope you have understood this, right? So here I will just write h plus 1, and just write h plus 1, right? Now let us look at minimum number of nodes for a full binary tree. For a full binary tree, what are the minimum number of nodes given height h? So let us take an example here the same way we have taken in for the binary tree. Let us say height equal to 3. Okay, now we need to draw a full binary tree. For example, we need to find the minimum number of nodes. Say for height equal to 1, let us take first height equal to 1, right? Is this the minimum number of nodes for a full binary tree? Actually, this is a binary tree, but this is not a full binary tree. Therefore here I cannot say that this is a full binary tree. First I have to make a full binary tree and then calculate the number of nodes, right? So here I have to say C. Only then will this become a full binary tree, and then now I can see here number of nodes are 3. Number of nodes are 3. So now for height equal to 2, right? Here for height equal to 2. Now if I just draw D and leave it, this is not a full binary tree because B has to contain at least 2 nodes. Now I'll say here E. Now is this a full binary tree? Yes. And these are the minimum number of nodes for height equal to 2. If I don't draw this, then this tree itself is not a full binary tree. Therefore I have to draw this for this tree to become a full binary tree, and then these are the minimum number of nodes. I don't need to draw nodes here again. If I draw nodes here, then it will become maximum number of nodes, but I want to find out the minimum number of nodes for a given height h. So for height equal to 2, these are the minimum number of nodes. So how many nodes are there? 1, 2, 3, 4, 5. So number of nodes equal to 5, right? Number of nodes equal to 5. Let us draw for height equal to 3. For height equal to 3, if I just draw like this, is this a full binary tree? No. This is not a full binary tree, right? So I write G here, I insert a node called G here. Now this becomes a full binary tree, and I don't need to draw any other nodes here because I want the minimum number of nodes. I don't want all nodes, I want the minimum number of nodes. So you just need to draw so many nodes such that those are the minimum number of nodes, and the tree becomes a binary, and a tree becomes a full binary tree, right? So here at height equal to 3, I just needed to draw or insert 2 nodes for the tree to become a full binary tree, right? If I do not insert this node, then this itself is not a full binary tree. So I had to insert the node G for this tree to become a full binary tree, right? So let us check the number of nodes here. 1, 2, 3, 4, 5, 6, 7. Number of nodes equal to 7. As you can see here, there is a pattern, right? There is a clear-cut pattern where here for height equal to 1, it is number of nodes are 3. For height equal to 2, number of nodes are 5. For height equal to 3, number of nodes are 7. So can I say number of nodes equal to 2h plus 1, number of nodes equal to 2h plus 1. For example, for height equal to 3, 2 into 3 plus 1, that is 7, right? So the formula here is n equal to 2h plus 1. Therefore here I will just insert here 2h plus 1. I will just write down here 2h plus 1. The minimum number of nodes for a full binary tree is nothing but 2h plus 1. The minimum number of nodes for a binary tree is h plus 1. H plus 1. Now let us look at minimum number of nodes for a complete binary tree. Again, we will take an example. We will say height equal to 3 and then solve this. So now let me take example for height equal to 1. For height equal to 1, A, B. For height equal to 1, this is a complete binary tree. Therefore, because if I just draw the array here, right, A, B, right, and then there is a gap here, I just leave the gap. There are no gaps in between A and B. Therefore, this is a complete binary tree, right, for height equal to 1, right. Now let me say for height equal to 2. For height equal to, if I draw C here, now let me draw an array here. I'll just draw it here. Let me draw an array here. So I'll say here I'll insert A first, then B, then there is a gap here, for height equal to 1, right? Then there is a gap, then I come, so I inserted A, I inserted B, first I finished off this level, then I come to this level, from left to right B, there is a gap. I have written a gap here, and then C, and then there is a gap here, right, and then there are two gaps here, right, and then there are two gaps. But here, as we can clearly see, there are gaps in between the nodes, right. We do not want to have this type of gaps. Therefore, this is not a complete binary tree, right. So to make it a complete, so it was a complete binary tree for height equal to 1, but when I try to draw a complete, or when I try to insert nodes for a complete binary tree for height equal to 2, it became incomplete. Therefore, for height equal to 2, I want to make it complete, right. So for that, I'll say D, C here, I'll say D here. Now can you please tell me whether it is a complete binary tree for height equal to 2? Yes. So again, let us draw this A, B. Now here I finish off this level. Now I come to this level. I say B, C, and then this level I just write D, and there are gaps here. I don't care whether there are gaps after the last node has been inserted. There are no gaps in between the nodes. Therefore, for height equal to 2, it is complete binary tree. For height equal to 1 also, it is complete binary tree, right? For height equal to 1, as you can see here, if I put C here, it is a complete binary tree. Therefore, for height equal to 2 also, this became complete binary tree with minimum number of nodes. I can also insert a node like this and say E. This is also a complete binary tree. If I say here E, this is also a complete binary tree. But what I need here is the minimum number of nodes, minimum. So if I just insert D and leave it, this will also be a complete binary tree. Please remember, it is minimum number of nodes. Correct? Minimum number of nodes. Now, for height equal to 2, this is a complete binary tree. But we are talking about height equal to 3 here. Right? Height equal to 3. So, if I insert E here, for height equal to 3, this becomes an incomplete binary tree for height equal to 3. So, for example, let me draw A, I finish off A, then B, C, right, and then I come to D, and then there is a gap here, right, I put a gap, then there are two gaps here, right, and then comes E, right, and then I leave a gap here, and then I leave a gap here, and then if there is a node here, there are two gaps, 1, 2, right, and then if there is a node, 3, 4, if there is a node, 5, 6. So here 1, 2, 3, 4, 5, 6. There are so many gaps here. I don't care if there are gaps after the last node. All I want is, I don't want to have gaps in between, but there are gaps in between the nodes, right? There are gaps in between the node D and node E. So therefore this is not a complete binary tree, not a complete binary tree for height equal to 3, right? For height till height equal to 2, it was a complete binary tree, but once we try to draw or insert minimum number of nodes for height equal to 3, it became an incomplete binary tree. Therefore to make it complete for height equal to 3, I just draw E, F, G, right? Now for height equal to 2 it is complete, and for height equal to 3 also it is complete, right? I just draw, so here H, right? H. So I'll just delete this now. This now for height equal to, let us see whether it is complete or not, right? Whether it is complete or not. So looking at it, you can know it is complete, right? So here A, now this level, I'll say here B, C, and then here D, this level, now here D, E, F, G, the last level is H, and it doesn't matter whether there are blanks here, any number of blanks, it doesn't matter, right? We should not have any gaps in between these nodes. We don't have. So therefore for height equal to 3, this is a complete binary tree, and these are the minimum number of nodes. I can also draw I here, I can insert I here. This is also a complete binary tree, but what I want is not all the nodes or some of the nodes. I want the minimum number of nodes for height equal to 3. So here if I just say H here, for height equal to 3, this becomes a complete binary tree, therefore I leave it here, right? So let us check. For height equal to 1, the number of nodes are 3, right? So here 1, 2, 3, number of nodes are 3, correct? So here for height equal to 3, we have drawn number of nodes are 3, but if you would have seen while drawing for height equal to 1, number of nodes are just 2. So this is okay, right? For height equal to 1, A and B, this is a complete binary tree. So for height equal to 3, while we were drawing, we inserted some nodes. So let us directly see for height equal to 3. So 1, 2, 3, 4, 5, 6, 7, 8. For height equal to 3, number of nodes equal to 8. So we can clearly reduce the formula that, I'll just write down here. So number of nodes equal to 2 to the power h, right? So here if height equal to 3, number of nodes equal to 2 to the power 3, that is nothing but 8, right? That nothing but 8. For height equal to 1, so here I will write here, for height equal to 1, 2 to the power 1, that is 2. For height equal to 2, 2 to the power 2, that is 4, right? So these are the minimum number of nodes given height h. Please do not think that for height equal to 1, the minimum number of nodes are 3. No, for this is for example purpose. This is for height equal to 3. So while drawing each and every height, we drew those nodes, but this example is only for height equal to 3. For height equal to 3, the minimum number of nodes are 8. For height equal to 1, the minimum number of nodes are 2. For height equal to 2, the minimum number of nodes are 4, right? So I just write down here 2 to the power h. So these are gate questions, wherein in the gate exam they might give you a height and they might ask you to find out the maximum number of nodes and the minimum number of nodes, right? For a binary tree, for a full binary tree, and for a complete binary tree. So the trick is, if you do not remember the formula, try to use an example to reduce the formula and then put the values to get your result, right? So I would like to repeat one more time that for complete binary tree, this example is only for height equal to 3. Please do not think that For height equal to 1, the number of nodes are 3. No, this example is only for height equal to 3. For height equal to 1, the number of nodes are 2, right? The number of nodes are, for height equal to 2, the number of nodes are 4. For height equal to 3, the number of nodes are 8. I hope you have understood this, right? So I hope you have understood binary tree, full binary tree, as well as complete binary tree. Thank you for watching this video. Meet you in the next video. Thank you.